minute film section here that kind of covers some of the places that I studied in China and Australia and Central and South America and Texas Sea Grant on the Gulf of Mexico, and putting together all the things that I studied and learned. And what our plan is to build a large commercial type center for plants and fish in raceways like we had in China. You know, today kids spend a lot of time on computers, but it's also good to be able to get outside a little bit and see the real world. But here we have a facility where we have the trout ponds that I've raised the trout in, trout fishing, so the kids can see the trout in the water. They can feed the fish and they can catch fish if they want. But we have aquariums on the side where we pour water and they can see through the sunlight the phyto and photoplankton, and it can be a really good educational experience.
So Rance, this was the Ellensburg U-Fish Park?
Yeah, Kevin. About 7 or 8 years ago, I dug these ponds and started out aquaculture with just trout, U-fish. But at that time, we had the salmon recovery event going on, so I started working with the people over at UW, and that kind of led into this other study in the Pacific Rim countries. Went to China and then went to Australia and worked on a farm there, and then started a little farm in Costa Rica and Texas A&M. And so I'm trying to put all that experience and information and knowledge together into a science park here for education.
Now, is this picture in Texas?
Well, it could be, but no, this actually is in Israel. The shrimp farms they have in Texas they're on the coast. This is all self-contained, which is kind of important to what we're doing. We're trying to solve the problem of aquaculture. There's problems in aquaculture, but I think we can solve those problems with the technology that we have now.
Well, what do the ponds look like in China?
Well, Kevin, the Taiwanese Fisheries Institute was established by the Rockefeller Foundation long ago, and they raise prawns. Black tiger prawns became a major producer around the world of these, and they have them just like you see here. They're just in indoor raceways. But we're taking that idea and expanding it to a greenhouse with fish and plants called aquaponics.
Is this the city pool?
Well, it could be the city pool, actually. It might be a good idea to develop community centers where people can learn about aquaponics, fish, vertical plantings, and this actually might be something we want to eventually have here.
So what do you plan on raising in these ponds?
Well, we're going to be, actually, we have the ponds for the trout outdoors, naturally, but indoors we have for herbivores and carnivores and crayfish. So it's all selected growing of these fish for actually commercial production. So here's the aquaponics cycle with the fish and the plants and how the whole system works. Now, what's important is that this is a closed system. There's no pollution going out into the rivers or the ocean or the streams. It's all a closed system. It's just it's the best science we have, and we need to use this now.
Is there any more advanced technology for building greenhouses instead of plastic and 2x4s?
Oh, absolutely, and that is so important. Look, let me show you here. Take a look at this picture. This was in the Daily Record. It was the straw bale facility that I built, and the idea was I was experimenting with material technology to see what would work for building a thermal greenhouse. Well, this worked. We built this and we oriented it for maximum winter sunlight, not total sunlight all year long, but the winter sunlight. And the system is right, and we're just now kind of perfecting it. But where we want to go now is building a greenhouse for thermal quality for winter all season growing of plants and fish.
So how exactly do you plan on constructing the thermal greenhouses?
Well, Kevin, here you can see the machine. It's a gunite machine, and we've refined our plasters. We've added styrofoam chips into the plaster. This machine sprays on or pumps on, so you can build like a swimming pool, or you can spray it on any kind of surface you want for a thermal plaster. Here you can see what we finally built, and here's the machine with test materials. And later we have a couple homes that we built with the machine. It's just spraying on plaster on straw bales, which is great. But for a waterproof thermal greenhouse, our technology has changed, and I think we've really got a solution here.
So you have a thermal plaster now?
Well, we do. It's basically all it is styrofoam. We recycle styrofoam with the chipper shredder. It chips it down to little beads and mixes right in the machine with a spray on or pump on to build a thermal swimming pool. And so it's easy. You can see there's two different varieties. We have the straw logs or the straw bales. We think maybe the straw logs might be better. We've tried every kind of possibility of making straw bales with the thermal concrete, but it's just too much trouble. But here's the system of just chipping and shredding the styrofoam. It's really an easy system. It makes I think it was 36,000 pounds of compression strength. I believe that's what the core was when we tested up with the Hogue Engineering. And it's fireproof, and these blocks float on water. So they're strong, fireproof, and thermal.
So you achieved the basic design of the straw bale?
Yes, that was our research for actually the last 10 years, trying to get a thermal greenhouse wall. So here we can see where we're coming to now is the straw logs. The straw logs are the simplest, easiest way to build like we had a 120-foot horseshoe-shaped facility, and you can see here in the picture what they have built in Israel. But this is much more complicated than our system, and so we can just build our basically thermal walls with these straw logs with the sprayed on thermal styrofoam plaster.
So what exactly are you going to grow in these greenhouses?
Well, the technology we have now is we've moved beyond just stapling plastic on 2x4s. Now we have solid thermal walls and floors, and every cubic foot of the inside of the greenhouse is used for vertical planting and for fish. So it's a maximum production facilities. Now the asparagus walls, we've tried this. They're just permanent gardens on the side of the thermal walls.
So Rance, you seem to have an urgency about building these thermal greenhouses.
Well, I think there might be. I'm a little concerned about Fukushima in Japan. It appears that they're really not solving that problem, and not like they did in Chernobyl. The Russians had 500,000 troops and personnel cleaning that whole area and sealing that in concrete, but Japan's doing nothing. It's right there on the water of the Pacific. So it's very likely that we're going to have increasing problems, and who knows how bad it's going to get. But that's that. I think we have a good solution here for the Pacific Northwest and the inland area where we get 300 days of sunshine, and I think we can build these community centers, these aquaponic greenhouses with fish and plants. It'll be an amazing educational site to bring kids. School buses, they can come out and a short hop up from Yakima or down from Cle Elum over from Wenatchee and feed the trout and learn about the fish and the water, and be a great science park. Here is the actual kind of what the facility will probably look nearly. It's solid walls, thermal walls, and you see the raceways for the fish inside, and the topsy-turvy plants from ceiling down, also vertical planting and column planting. So it would really be an educational experience to learn all about nature.